Hello guys, this is Saroj Singh and in the series of our AWS Solution Architect course. So today we are talking about AWS security and encryption services. So basically here we talk about KMS, encryption SDK and SSM parameter store. So let's move further. So why encryption is important? So encryption is important because no third party can access our sensitive information. Either it is if our information in transit state, either it is in rest state. So let's talk about encryption in flight. So encryption in flight is basically maintained by using SSL or TLS. So basically we generally use SSL, although we are using nowadays TLS, but TLS is also termed as SSL. Although both are two different concepts. So here data is encrypted before sending and decrypted after receiving, and SSL certificate helps with encryption, and encryption in flight ensures no MITM can happen. So basically MITM is man in the middle attack, so no sniffer can sniff our data. Basically after getting this encrypted key, if any hacker is advanced, then he can basically decrypt that key also. Like here, if you take an example, here is basically our system, and here is website where HTTPS is enabled. So here if we write our username admin, password super secret, then it is going to encrypted before in transition state. So if this admin super fast admin and our password is here encrypted, and this encrypted user ID and password is going to transit in network and basically goes on website, and then there basically this is decrypted. So here on client side SSL encryption is performed, and server side SSL decryption is performed. Okay, so if any sniffer or hacker get this user ID and password, then it is encrypted. So he or she is not able to understand what is username and password of our clients. So let's move further. So let's talk about some more encryption concepts. So basically SSL and TLS help us to encrypt the in-flight data, but what about the rest data which is stored in on any storage device, like which is stored in S3 or EBS or many more. So let's talk about server-side encryption at rest. So basically here our data is encrypted after being received by the server, and data is decrypted before being sent to our client, and it is stored in an encrypted form thanks to key, usually a data key. And the encryption or decryption key must be managed somewhere, and server must have access to it. So like if you take an example, here is our object is transferred by using hypertension transfer protocol security, and here we encrypt by using data key, and here encrypted we store it in encrypted form, and then if user requires this object, then here we perform decryption by using this data key, and then we transport it over the SSL, hypertension transfer protocol SSL, to our users. So here is our raw object. So let's move further. So let's talk about client-side encryption. So basically data is encrypted by our client and never decrypted by the server, and data will be decrypted by a receiving client, and the server should not be able to decrypt the data. It could leverage envelope encryption. So here is our object. Here cloud uses her own data key to encrypt this object, and then basically this encrypted data is transferred to our any storage device over FTP or any, like here we can store it to NFS or S3 or any storage device. and here it is stored in encrypted form because of this data is encrypted at client side, and here no decryption is performed. But when client want to receive this data, then after receiving this encrypted data by using client side data key, we decrypt that data, and now our client can access this object. So let's move further. So let's talk about AWS KMS. Basically, anytime we hear about encryption in AWS services, it most likely KMS, because KMS manages all the key which are basically used in overall AWS account. So it is easy way to control access to our data. Basically, AWS manages keys for us. Here it is fully integrated with identity and management for authorization. It has seamless integration with Amazon EBS encrypt volumes and Amazon S3 server-side encryption of object, and Amazon Redshift encryption of data, Amazon RDS encryption of data, Amazon SSM parameter store, and many more. So we can also use command line interface or SDK to basically leverage the advantages of key management services. So let's move further. So let's talk about KMS, customer master key. So basically, key management services has a concept of customer master key. So basically, customer master keys are two types: symmetric and asymmetric. If you are using CMK with symmetric, so then it uses AES 256 keys. So basically, AES stands for Advanced Encryption System. And here, first offering of KMS single encryption key that is used to encrypt and decrypt. And here, basically, when we talk about symmetric key encryption, symmetric key cryptography, then here we uses the same key for encryption and decryption both. And AWS services that are integrated with KMS use symmetric customer master key, and necessary for envelope encryption, and we never get access to the key, basically unencrypt it, and we must call KMS API to use it. So let's talk about asymmetric. Basically, in asymmetric cryptography, we use both two concept of two keys, which is known as public key, and the second one is known as a private key. So here, public key is used for encryption and private key is used for decryption. So basically, asymmetric key cryptography uses a pair of keys, like RSA and ECC key pairs are asymmetric key encryption algorithms. And here it is used for encrypt and decrypt or sign or verify operation. The public key is downloadable, but we cannot access the private key unencrypted. And use cases like encryption outside of AWS by users who want to call the KMS API, like when we basically download our ESS. When we are going to start our EC2 instance, then we have to download a RSA key pair to connect by using SSH from our EC2 instances. So basically here, where our public key is saved on our EC2 instance, and we download our private key to access our EC2 instance by over the SSH. So let's move further. So let's talk about AWS Key Management Services, some more concept. So here it's able to fully manage the keys and policies. Like we can create keys, we can add rotation policy as keys, we can disable key, we can enable key, and here we are also able to audit key usage like using CloudTrail. And there are three types of customer master keys. First one, Amazon Web Services Managed Service, default CMK, and it is free. And user created KMS, in KMS we have to pay $1 per month, and the user key is imported must be 256-bit symmetric key, and we have to pay $1 per month. Plus we have to pay for API call to KMS, like $0.03 for 10,000 of calls. So let's move further. Let's talk about AWS KMS 101. So basically anytime we need to share sensitive information, we have to use KMS, like our database password, credentials to external services, and private key of SSL certificates. And the value in KMS is that the same key used to encrypt data can never be retrieved by the user, and the same key can be rotated for extra security. So here, never ever store your secrets in plain text, especially in your code. And encrypted secrets can be stored in the code environment variable. And KMS can only help in encrypting up to 4 KB of data per call. If we want to store more than, if we want to encrypt basically more than 4 KB of data, then we have to use envelope encryption. So to give access to KMS to someone, we have to make sure that the key policy allows that user, and we also have to make sure that IAM policy allows the API calls. So let's move further. So let's talk about copying each snapshot across regions. So basically here we are in region AP West 2, and here is AP Southeast 2. So these are both two different regions. Here our EBS volume is encrypted with KMS key A, and let's suppose we make a snapshot of this encrypted volume with KM. So here now basically KMS re-encrypt with KMS key B to basically what? Here when we transfer, always remember a snapshot from one region to another region, then must be the region key of this region will be applied in this EBS snapshot. So here we have to use KMS key B to decrypt this. So here our EBS volume encrypted with KMS. So here we can decrypt only by using the KMS key B. Because when we are transferring basically snapshot across region, then it must KMS must re-encrypt with KMS key of B, which is available in second region. So let's move further. So let's talk about KMS key policies. So basically we have to control and access to KMS key similar to S3 bucket policies. And difference, here we cannot control access without them. And default KMS key policy is created if you don't provide a specific KMS key policy, and it has complete access to the key to the root user is equal to entire AWS account, and it gives access to the IAM policy to the KMS key, and custom KMS key policies define. Basically these are defined by users or roles that can access the KMS key, and it can define who can administer the key, and it is useful for cross-account access of our KMS key. So basically here is an example of copying snapshot across account. So here we create a snapshot encrypted with our own customer master key, and we attach a KMS key policy to authorize cross-account access. And here we share the encrypted basically here we share the encrypted snapshot, and in target we create a copy of the snapshot and encrypt it with a KMS key in our account, and here we create a volume from the snapshot. So basically this is the our KMS policy which allow is, so it is ID. So here ID is allow use of the key with destination account. If it is allow, principal is our AWS ARN, basically resource name, application resource name, and AWS IAM target. Here we have to get target account ID and role name. What and action, here we can decrypt that KMS, and basically here we then after decrypting they can basically encrypt this by using our own key. And the resources is here all resources is allowed, and condition if string is equal to KMS by service like EC2 region and AWS.com. So if this is the region, then by this service, then here is KMS caller account, here is our target account ID of caller. So basically this is a sample of KMS key policy. So let's move further. Let's talk about KMS auto key rotation. For customer managed key, basically customer managed, sorry for that, for customer managed customer master key, we can basically, if it is enabled, then automatic key rotation happens for every 1 year, and previous key is kept active, so we can basically decrypt all data. And new key has the same key ID, only the backing key is changed. So basically what it is, there is example, here it is backing key and here is some key ID, and here after automatic key rotation our backing key is changed, whereas our key ID is changed. Okay, so let's move further. Let's talk about KMS manual key rotation. So basically when we want to rotate key after every 90 days or 180 days or after 30 days, then here we have to use KMS manual key rotation, and it is basically generate a new key has a different key ID and different, basically this ID also is different. So basically it keeps the previous key active, so we can decrypt all data, and better to use alias in this case, basically to hide the change of the key for the application. So good solution to rotate CMK that are not eligible for automatic rotation like asymmetric CMK. So like here is our client and here this is key ID, and after rotating this key ID is changed, and also this key ID is also changed. So here our alias is not changed. So when we are going to use a manual key rotation, then always use alias. Okay, so let's move further. So let's talk about KMS alias updating. So basically it is better to use alias in the case to hide the change of key for the application. Like here is our application and here is our key alias my app key. After updation, this is our old key and our same key ID changed, but not our key alias is changed. So this is the overall funda. Here our application will view our key alias, like my key alias is not changed. Basically my key alias is my app key. So let's move further. Let's talk about SSM parameter store. So basically it is a secure storage for configuration and secrets, optional seamless encryption with KMS, and it is serverless, scalable, deliverable, easy SDK, and it has version tracking of configuration or secrets, configuration management using path and IAM, and notification with CloudWatch events, and it can integrate with CloudFormation. So here is an example, like our application gave the plaintext configuration to our SSM parameter store, and then he checked the IAM permission, and then after he encrypt our configuration. So when we have to decrypt, then we have to perform decryption services by using AWS KMS. So let's move further. So let's talk about parameter policies for advanced parameters. Sorry for that. Let's talk about standard and advanced parameter tiers. So basically here we have total numbers of parameter allowed in the standard. We have 10,000 allowed in, whereas in advanced we have 1 lakh basically parameters are allowed. And maximum size of parameter value in the standard is 4 KB, whereas in advanced is 8 KB. And parameter policies available. So in standard there is no parameter policy available, but in advanced there is availability of parameter policies. So here we did not have to pay any additional part, but when we are going to use advanced parameter store, then we have to pay some charges. And here storage charges is also free, but we have to pay $0.05 for advanced parameter per month. And here API interaction price is basically higher throughput is equal to up to 1000 transactions per second. So standard throughput is free, but higher throughput, for higher throughput we have to pay basically $0.05 per 10,000 API interactions. So basically in advance there is no fee, 3 API interaction is available. You have to pay $0.05 for 10,000 API transaction, and for higher throughput you have to pay $0.05 for 10,000 API interaction. So here we get higher throughput API interaction. So let's move further. So let's talk about parameters policies for advanced parameters. So here we can allow to assign a TTL value to our parameter. Basically TTL is nothing but an expiration date to force updating or deleting sensitive data such as password. We can assign multiple policies at a time. So here let's suppose we want to delete a parameter, then we assign this policy. Basically here attribute is saved to timestamp in this manner, and here expire we want to basically send CW events. Then here is expiration notification, and here is version, and here is attribute set before 15 and United States. And here if we want to change no change notification, basically CW events, then here we no change event notification, and version is this, attribute is after 20 days. So basically these are some example of advanced parameters. So let's move further. So let's talk about AWS Secret Manager. Basically it is a new service meant for storing secret and capability to force rotation of secret on every access. It can automatically generate secrets on rotation. Basically it is integration. It has integration with Amazon RDS, MySQL, PostgreSQL, and Aurora. Secrets are encrypted by using KMS and mostly meant for RDS integration. So when we are talking about AWS Secret Manager, then we are talking about the RDS. So let's move further. Let's talk about AWS Shield. So basically AWS Shield is a standard and free service that is activated for every AWS customer, and this provides protection from attacks such as SYN and RDP flows, reflection attack, and other layer 3 and layer 4 attack. So when we talk about AWS Shield standard, basically advanced, sorry for that. And then here we have optional DDoS mitigation service. You have to pay $3,000 per month per organization, and it protects against most sophisticated attacks like an Amazon EC2, ST Cloud Balancer, Amazon Confirm, AWS Global Orchestrator, and Route 53, and we have 24-hour access to our AWS DDoS response team, and it protects against higher fees during usage spike due to the DDoS. So let's move further. Let's talk about cloud assessment. Basically, it's when we are talking about KMS, then it is a AWS manage the software for encryption. But when we are talking about cloud as system, then it's provision encryption hardware, and basically SSM is a dedicated hardware, and SSM stands for hardware security module. And here we can manage our own encryption key entirely, not AWS. Here SSM device is tamper resistant, and it follows the FIPS 142 second level and third level of compliance, and it supports both symmetric and asymmetric encryption by using SSL or TLS key. So there is no free tier available, must use the cloud SSM client software. And here Red Shift support cloud SSM for database encryption and key management. So it is good option to use it with server-side encryption by client managed key. So let's move further. So here is a basic diagram of cloud SSM. So basically here AWS manage the hardware, and here we are using AWS Cloud SSM, and here is our basically Cloud SSM client. Basically it uses IAM permissions, CRUD and SSM cluster, and Cloud SSM software mainly is used for to manage the key and to manage the users. So let's move further. Let's talk about Cloud SSM high availability. So basically Cloud SSM cluster are spread across multiple availability zones, and it is basically great for availability and reliability both. Like here our Cloud SSM 1 in availability zone 1, and here our Cloud SSM 2 in availability zone, and both are interconnected with high speed internet, and they are also connected with Cloud SSM. So let's move further. Let's talk about some differences between Cloud SSM and KMS. So here if we talk about features, so basically here we differentiate based on their features. Like if we talk about tenancy, then AWS KMS is multi-tenant, where is AWS Cloud SSM is single tenant. And here basically AWS KMS follow the standard of FIPS 140-2 level 2, and it follow the level 3. And if you talk about master key, then KMS has AWS owned CMK, AWS managed CMK, and customer managed CMK. But here in AWS Cloud SSM we have only customer managed CMK. And here if we talk about key types, then it uses symmetric, asymmetric, and registered secondary. But here if we talk about AWS Cloud SSM, then it also uses register signing and hashing. And if you talk about key accessibility, then KMS key is accessible in multiple AWS region, and cannot access key outside the region it is created in. And here AWS, if we talk about Cloud SSM key accessibility, then it is deployed and managed in a VPC and can be shared across VPC by using VPC peering. And where we are talking about cryptographic acceleration, then here each none acceleration is available, whereas in AWS Cloud SSM SSL TLS acceleration and Oracle TD acceleration is available. When we talk about access and authentication, then when we are using AWS KMS, AWS IAM is used for giving access and authentication. Whereas in AWS Cloud SSM we create users and manage their permission. So let's move further. And let's talk about some more differences, like high availability. Basically AWS KMS uses AWS managed service, and AWS Cloud SSM is deployed in multiple SSM over different availability zones. And when you talk about AWS KMS, then it does not support MFA, but AWS Cloud SSM support MFA. And AWS KMS comes with free tier, whereas AWS Cloud SSM is not comes with free tier. So let's move further. So let's talk about AWS Web Application Firewalls. So basically, Web Application Firewall protect our web application from common web exploit. So basically, these exploits are work on layer 7, and layer 7 is HTTP versus layer 4 is TCP. So we can deploy it on application load balancer, API gateway, or CloudFront. And it basically define web access control list, and rules can include IP addresses, HTTP headers, HTTP body, or URL strings. And we can protect from common attacks like SQL injection and cross-site scripting, and size constraints like geomatch, block countries, and rate-based rules to count occurrence of events for DDoS protection. So let's move further. So let's talk about AWS Firewall Manager. So basically, AWS Firewall Manager manages the rule in all accounts of an AWS organization. And here, common set of security rules like web application firewall rules, and application load balancer, and API gateway, and CloudFront. So basically, AWS Shield Advanced can be also used with ALB, CLB, Elastic IP, and CloudFront, where the security group is for EC2 and ENI resources in VPC. So always remember both these basically, like web application firewall rules can work with these, and AWS Shield Advanced can also work with these, but there is a difference. AWS Shield Advanced can also work with Elastic IP, but web application firewall does not work with Elastic IP. And security group is basically for EC2 and ENI resources within a VPC. So let's move further. So let's try to basically understand this sample reference architecture for DDoS protection. Like, we have some users and we are using root 53. Then root 53 can be protected by AWS Shield, and here our CloudFront distribution can be protected by both AWS Web Application Firewall or by using AWS Shield. And here in our public subnet, our Elastic Load Balancer is protected by AWS Shield. And here our basically auto scaling group, and at subnet level we can also basically use access control list to protect this whole subnet. And here we can also use subnet level security by using the network access control list. And here our EC2 instances are protected by our security group. So this is the basic sample reference architecture of using AWS Shield, AWS Web Application Firewalls, and network access control list and security group. So let's move further. So let's talk about Amazon Guard Duty. So basically, Amazon Guard Duty is an intelligent threat discovery to protect AWS account. It uses machine learning algorithm for anomaly detection or third-party data for the same. And here we can enable it for 30 days in free trial. We don't need to install this software. Basically, input data may include CloudTrail logs, VPC flow logs, and DNS logs. So basically, for detecting unusual API calls or unauthorized deployments, we can use CloudTrail logs, and by analyzing VPC flow logs, we can detect unusual internet traffic and unusual IP addresses. By analyzing DNS log, we can get compromised EC2 instances sending encoded data within the DNS queries. So basically, we can set up it with CloudWatch events rule to be notified in case of findings. And CloudWatch events rule can target AWS Lambda or SSM and can protect against cryptocurrencies attack, and it has a dedicated finding for it. So Amazon guard duty is like our guard duty, work for our protect to our college. So let's move further. So basically here is example of guard duty, like over here we are actually analyzing VPC Pro log, CloudTrail logs and DNS log by using guard duty, and if any unusual activity or anomaly is present in this logs, then it's basically trigger a CloudWatch event, and then further let's talk about Amazon Inspector. So basically Amazon Inspector is an automatic security assessment for EC2 instance. It analyzes the running operating system against known vulnerabilities, and it can analyze against unintended network accessibility. AWS Inspector agent must be installed on operating system in EC2 instances. After the assessment, you get a report with a list of vulnerabilities and possibility to send notification to SMS. So basically this is the diagram. Here Inspector agent is installed and Inspector services run assessment run for findings, and after finding it can send to basically trigger to an SMS topic and rest So this is the diagram of to understand Inspector. So basically an alternative of this Inspector, we can also use some third-party tools, like we can use Professional, and many more are also available for the same purpose. So let's move further. So what does basically AWS Inspector evaluate? So always remember, it is only for EC2 instance, and we have to install it on our operating system. And for network assessment, it is maybe agentless, and it's overall depend on network eligibility. For host assessment, we have to must install a agent to find common vulnerabilities and exposures, and Center for Internet Security benchmarks. So basically it is just CIS benchmark, and it also gives suggestions for security best practices. So let's move further. So let's talk about Amazon Key. So Amazon Key is a fully managed data security and data privacy service that uses machine learning and pattern matching to discover and protect our sensitive data in AWS. And Key helps identify and alert me to sensitive data such as personally identifiable information (PII). So always remember, Key helps with protecting PII, which is personally identifiable information. Like we have S3 bucket, and then Key analyze this S3 bucket to discover sensitive data like personal identifiable information and notify to CloudWatch events breach. And basically we know CloudWatch event breach can integrate with basically it is also known as CloudWatch events, or it's also known as event breach. So rest of So let's move further. Let's talk about AWS shared responsibility model. So basically this model is very important model. This is also a basic model, but you have to remember this model. So basically here AWS responsibility is security of the cloud, whereas our customer responsibility is security in the cloud. So security of the cloud is responsibility of AWS, but security within the cloud is responsibility of our customer or ourselves. So protecting infrastructure like hardware, software, facilities, and networking that runs all the AWS services, like managed services like S3, DynamoDB, RDS, etc. are the responsibility of AWS. But what is the responsibility of customer? Is customer have no responsibility? No. So for protecting EC2 instances, customer is responsible for management of the guest operating system, including security patches and updates, and firewall and network configuration, IAM, and many more. And user also had to take care of encryption of application data. And here we have shared controls on patch management, configuration management, and awareness and training. So let's move further. Let's take an example of RDS. So here AWS is responsible for managing the underlying EC2 instances and disabling SSM, ISS, and automatic database patching, and automated operating system patching, and audit the underlying instances and disk guarantee to function it. So in taking RDS, So what is our responsibility? Basically our responsibility is check the ports, IP, security group inbound rules in database security group. And in database user creation and permission is also responsibility of ourselves. So creating a database without public access, insert parameter groups or database is configured to only allow SSL connection and database encryption settings. So basically all the responsibility of ourselves. So let's move further. Take one more example of S3. So basically here AWS is responsible to guarantee you get unlimited storage, guarantee you get encryption, ensure separation of data between different customers, and ensure AWS employee cannot access our data. So what is our responsibility here? Here bucket configuration and bucket policy and IAM users and roles and enabling encryption is a responsibility of ourselves. So let's move further. So let's understand the shared responsibility model diagram. So basically here, which is basically described in yellow section, it is a responsibility of AWS, and is described in blue section is a responsibility of customer. So basically if we talk about AWS, then it is clearly mentioned as I discussed in previous slides. It is a responsibility, AWS is responsible for security of the cloud. So always remember, security of the cloud is the responsibility of AWS, whereas security within the cloud is the responsibility of customer. So here like regions, availability zones, edge location, hardware of AWS global infrastructure, compute, storage, database, networking, and software. Basically it is talking about software that is basically given by the AWS. And also here AWS is responsible for host operating system. So this operating system is different. This operating system, which is basically managed by customer, is called guest operating system. So basically in software section, host operating system is also included here. Like here customer is responsible for client-side data encryption and data integrity, authentication, and server-side encryption, file system or data networking, traffic protection, encryption, and integrity, identity, and operating system. So basically here we are talking about the guest operating system, not for the host operating system. Host operating system is responsibility of AWS. And also customer managing customer data is also responsibility of customer. So let's move further.